Today we're going to be looking at section 1.3 again, so we're going to be sticking with equations with variables on both sides. But today we're going to be looking at some modeling real-life problems. So these problems are going to be actual solving some actual problems that you might encounter out in the real world. So let's go ahead and get into things here. So the first question says, if possible, find the value of x so that the value of the perimeter is equal to the value of the area. Use an equation to justify your answer. Okay, so we are going to try to figure out for these two rectangles, is there a value for x? Is there a value for x in which the perimeter can be the same as the area? Let's find out. So here's where we're going to start. Perimeter. We got to make sure that we know what perimeter and area are. So perimeter and area. Excuse me. Again, we should be writing this down, following along with me. All right, so the perimeter, guys, the perimeter, hopefully we remember this. If not, it's okay. But the perimeter of any object is every single side added up. Okay, it's the distance around the outside of an object. So if I were to write an expression for the perimeter of this rectangle, I would have my length and my width twice, and I would add them all together. So I would have two lengths. I would have x plus 3 plus 3, right? Every single side added up together. The length, the width, the length, and the width. Okay? So the expression for this first rectangle representing the perimeter would be x plus 3 plus 3, which is just simplified down to 2x plus 6. It's basically the length doubled, the width doubled, add them together. The area of a rectangle is just length times width. So length times width. All right. So this would just be x times 3, or in other words, 3x. All right. Now, the goal here is to figure out, can the area, so can 3x, can the value of 3x ever be equal to the value of 2x plus 6? Well, let's find out. We can set up an equation that says exactly that. Okay, let's see, what does x have to be in which 3x will equal 2x plus 6? All right, let's go ahead and solve that. So we've got variables on both sides. I need to move my variable term to one side. I see this 3x here on the left. That's good. That makes me happy. That means this one's going to be quick because I already have a variable by itself on one side of my equation. So I'm going to move the other variable term over to that side. It's going to give me, I'm going to subtract 2x from both sides. That's going to give me 1x, aka x, I should do my line here, equals 6, and we're done. Okay, so x equals 6. All right, and again, see if that's true. If x is equal to 6, that would mean that 2x plus 6 would be 2 times 6 is 12. 12 plus 6 is 18. Okay. Is 3 times 6 18? Yeah, it is. So the perimeter is equal to the area. So the only time in which this will happen is if x is equal to 6. Let's see if I can erase. There we go. Uh-oh, that's going to bother me. I don't like that. There we go. Alrighty. Let's try the next one. All right, so the perimeter here of this rectangle, perimeter would be represented by, that's a weird arrow. There we go. Oh my gosh, I'm a disaster. Let's try this again. The perimeter would be x plus 2 plus 2, or just 2x plus 4, right? X plus 2 plus x plus 2. That's the perimeter, aka 2x plus 4. The area would be the length times the width, which would be x times 2, aka 2x. So let's see. Let's set up an equation that says, okay, I need the area to equal the perimeter. So I need 2x to equal 2x plus 4. Just by looking at this equation, hopefully a little alarm is going off in your head and be like, wait a second, this doesn't seem normal. Let's go ahead and solve it. So I'm going to move my 2x on the right over to the left, and I'm left with, this is interesting. Both of my x terms cancel out. When we cancel out, when I say cancel out with addition and subtraction, I mean 0. So we have 0. We're left with 0 equals 4. 0 equal 4? Heck no, 0 isn't equal to 4. Not true. In the last video, when this happened, when our variable terms canceled out and we were left with a false statement, that means that there is no solution. Okay? No solution. All right? And just think about that just from a common sense mathematical standpoint. If I just look at the original equation right here of 2x equals 2x plus 4, how can 2x ever be equal to 2x plus 4? Because I'm always going to be adding 4 to 2x, and I'm going to have a plain 2x. It just doesn't fundamentally mathematically make sense. So that means that this is not possible. And did you notice? This is always key here, if possible. So that right when it says if possible, like, so there's a good chance that we might have one that's not possible. That's this one right here. It is not possible to have a 2 by x rectangle and ever have the perimeter equal to the area. It's not possible. Okay? All right. 2 more examples, guys. One more slide. Just want to do these 2. All right. I got 2 cars here. Modeling real life. Write and solve an equation to find the number of miles you must drive to have the same cost for each of the car rentals. Write and solve an equation to find the number of miles. So first off, I need my variable to represent something. So I'm going to say, okay, cool. I'm going to let my variable, I'm going to say m. Let m be number of miles. So I'm going to use the variable m here. Okay? Let m be number of miles. Here are my two prices that I'm getting from this car rental company. All right, I think that's blue. Fun fact about me, Mr. Ozinga, that I am colorblind. I have a really hard time with blues and purples. So I think that's blue, but it kind of, I don't know. Maybe it's purple, but if it's purple and I say blue, just pretend it's blue. So the blue car costs $20 plus you have to pay 50 cents a mile. The red car costs $30, but you have to pay 25 cents per mile. So the blue car, let's get some expressions written here. If that car's actually purple, I'm gonna laugh because that would be kind of ridiculous that I'm calling it the wrong color this entire time. The blue car is going to be a flat rate of $20 plus 50 cents per mile. The red car is an upfront cost of $30 plus 25 cents per mile. So the red car costs less per mile, but you have to pay more upfront. So let's see. Let's find out, okay, how many miles do I need to drive to have both of these cars cost the same? Okay, so basically all we need to do, guys, is set up an equation that says exactly that. Okay, when will 20 plus 0.50 m equal 30 plus 0.25 m? Let's figure out what m needs to equal to make these two expressions equal to each other. All right. Okay, so I got variables on both sides. I am going to move this m term over to the left-hand side of my equation. So I'm going to subtract 0.25 m. I'm a little bit limited on space here, so try to write small. So my m term is going to cancel here. I'm left with 20 plus 0.25 m. 0.50 minus 0.25 is just 0.25 equals 30. Okay, I'm going to subtract 20. So now I just have a pretty simple two-step equation. I'm going to subtract 20 here. And I'm left with 0.25 m equals 10. Okay, and then I would want to divide both sides by this 0.25. Divide by 0.25. That's going to cancel my 0.25 here. And that's going to give me, and by all means, use a calculator. Dividing decimals is tricky to do mentally sometimes. I do know that 0.25 is 1/4. 10 divided by 1/4 is the same thing as just 10 times 4. So m is equal to 40 miles. You're like, wait, we're dividing. How is my number getting bigger? If you divide a number by something less than 1, that number will actually increase. So it will take 40 miles. You will have to drive 40 miles to get these two rental costs to be the same. And this is actually, I mean, obviously, you guys probably aren't going to worry about this for a while because you can't rent a car. I don't know, you're like 25 years old. You can't rent a car until you're like 25, something like that. But when the time comes, this is a nice thing to sit down and try to figure out. Okay, which one's the better deal? How many miles am I driving? Would it be better for me to go with the blue car or the red car? All right. Okay. One more question, guys. One more. All right, I'm going to extend the page here a little bit. There we go. Give myself some more. And again, I know I'm moving fast, guys, but it's recorded. So if you need to rewatch something, if you need to go back and rewind or whatever, click pause and catch up. Go ahead, do so. All right, I do need to erase this so I can read the next problem. All right, last one. A cable television provider charges $75 for installation and $39.96 per month for a basic entertainment package. A satellite television provider offers free installation and charges $13.32 per month for service for each television. Your neighbor subscribes to the cable provider the same month that you subscribe to the satellite provider. After how many months is your neighbor's total cost the same as your total cost when you own 3 televisions? Okay, a lot of information going on here. Lots. So let's kind of break it down and just read through one part at a time, one sentence at a time. So a cable television provider charges $75 for installation and $39.96 per month. A satellite television provider offers free installation, so you don't pay anything for installation, okay, and charges $13.32 per month for each television. That's important. That is very important. I actually overlooked that part when I first solved this question, and it wasn't making sense to me. And so when I went back and read through it, I said, for each television, that comes into play. Your neighbor subscribes to the cable provider. You subscribe to the satellite provider. You own 3 televisions. Okay, that is factored into your price. Okay, let's go ahead and write some things out. So your neighbor, I'll do that to try to stay consistent. Your neighbor, he gets cable. His price is $75 up front plus $39.96 per month. I'm gonna have my variable be M, $39.96 per month. You get the satellite. Okay, I should stick with blue here if I'm going to be consistent. You get free installation and $13.32 per month per TV. You own 3 TVs. Okay, so your price is $13.32 per month times 3 televisions. Right? So isn't that actually $39.96 M? 1332 times 3 is 39.96. Okay, and we need to figure out, okay, how many months will it take for your neighbor to be paying the same as you? So when will 75 plus 39.96 M be the same as 39.96 M? Okay, again, right off the bat, if you just take a second and think about this, you should realize that there's something strange about this problem. All right, I'm not even going to solve this yet and just talk about just looking at this and realizing that something is weird. How can 75 plus 39.96 M be equal to 39.96 M? That just mathematically does not make sense. Something's not adding up here. So let's see how we would answer this question. So if I were to do this mathematically, go ahead and solve it. I would subtract this variable term. I would move it over to the right. But you'll notice here that both of my M terms cancel out. And I'm left with 75 equals 0. And we know that when this is not true, that's not true. It is no on On solution? How about no solution? That's funny. No solution. Okay. It's not possible. Okay. So the question asks after how many months? 0 months, no months, never. Never. It's not possible. You will never be paying the same as your neighbor. Your neighbor will always have a total cost that is more than you, because not only does he have to pay the $39.96 per month just like you do, but he also had to pay $75 for installation at the beginning. Okay. And and you can see, like, right when we get the equation written out, you can see, okay, this doesn't make sense. This is not possible. Okay. All right, guys. Thanks for watching. I will see you soon. I don't think I put any questions on the end of this video, so I think you guys are good to go. Okay. All right. We'll be practicing these soon, so I'll talk to you soon. Have a great day.